Um, I'm currently working with Facebook, but not directly with an IT company, EOS. So I
Okay.
do more like operational engineering.
Okay.
So it's more Cisco, Aruba, Arista, Juniper. So I'm looking to like get more familiar with Juniper because
Yeah.
I'm more geared with Cisco. So they're predominantly
Nice.
Juniper.
Yeah, David.
Oh, we're gonna
Yeah,
be
that's gonna be
best
best
friends,
friends.
buddy.
Yeah. Yeah. Let me see who
I
else we
love the
got here.
practical side of the networking, like I enjoy the stuff.
Absolutely.
Yeah.
Absolutely. Let me see. Y'all guys were y'all just talking with Jared not too long ago? Oh no, that was in the Slack room. Jared, can you hear me?
Yes, I can hear you.
How you doing? You want to tell a little bit about yourself there?
Yes. So Jared, getting into networking, studying for the CCNA. I was working with David earlier in the year. Took not a little break. I took a break, but getting back into it, and I'm just looking forward to just getting this first certification, and diving into networking. I've kind of made a path for myself, so just trying to execute.
Okay, that's good. Yeah, we all need that break. That mental, this is a field, and this is real talk here. This is a field where, some heavy demands can get placed on us and we can get burnt out quickly, especially when, like Carlos was saying, they want you to wear that Juniper hat. They want you to wear that Cisco hat. They want you to wear that Aruba hat. They want you to wear that Meraki hat, you know.
Mhm.
Uh, and like I said, this is something that you definitely can get burnt out, especially when we're working from home, because even when we're working from home, uh, sometimes our employers have a tendency to push a little bit more on us, because we got a little bit more time because we're not having to deal with any commutes and things like that. So
Right.
yeah, there's nothing wrong with that break, man. That's good
Okay.
deal, good deal. Let me see who else we got in here. We got somebody on
Paul,
the
I'm just
iPhone. Yeah, we got somebody on the iPhone.
I'm finished. I'm finishing up the last access switch. So
Yeah,
if you just
no
give me
problem,
like
no problem, no problem,
cool.
no problem. I'm not sure if that iPhone is Aaron or not. I don't know if he joined us
Yeah,
tonight.
it's me, Claude.
Hey, what's up, man? How you doing?
Hey, bro, how are you? Happy holidays.
Same to you. Same to you. You want to talk to some of the newcomers that's in here tonight about who you are?
Okay, yeah, that's cool. Hey, my name's Aaron Shaw. I'm
Uh-oh.
Uh-oh. Whoopsies. Aaron, you there? We lost you, buddy. No worries. We'll come back to
Yeah,
Aaron.
he muted. He muted. Let me see.
Oh, you muted? Okay.
Kelvin. That's Kelvin.
How you doing?
Hey, what's up, man?
Nothing much. How you doing today?
I'm all right. Yeah, go ahead and tell some of our guys, what you up to these days.
My name is Kelvin Lewis. Currently I'm a technical consultant engineer with Cisco on the enterprise routing and switching team. At the top of the year in January, I plan on starting studying for my DevNet certification. So that's what I'm working on right now.
fabulous.
Yeah, so y'all guys already know the term TAC. Those are the guys that want that smoke.
Yes.
So yeah, okay. All right. So yeah, we got a pretty good group tonight here. And like I said, this is gonna be it's nothing stressful. We all here to learn. And like I said, I know I'm not even gonna act like I'm the be all. I'm a student just like you guys are. Okay. And despite what Dave says, I make mistakes too. So, but so like I said, he's putting together we've been doing this on Eve. I think a lot of y'all guys are actually familiar with that if y'all haven't heard about it already. So yeah, he's Eve. And I myself, I use actual gear. I got I got some boxes in my room here that just heats up. You know, it's good in the wintertime. You know, it keeps the room warm. But yeah, I be catching hell in the summertime. I ain't gonna lie to you. I ain't gonna lie to you. You know.
Over there, the white beater looking like
Exactly.
Sweat. No fans, no nothing.
Talking about why my putty yelling at me. Yeah. Okay. So yeah, like I said, what you're gonna see here tonight is the typical campus setup, where we got I want to say there was roughly 8 to 10 access switches, and they're both connected. They're connected to 2 distribution switches, and of course, there's some redundancy between those connections there. So you have, what you will see is distribution switch 19 and 20, okay? And the access switches will have a link going to each one of those, all right? Now, the way he has it all laid out, the actual links are like, they got different colors. So it'll pop once you see it, you know? And the 2 distributions are going into a single core, okay? And that single core goes to as well as the other building. Okay, like I said, so there's 2 buildings on this property, and it's the same setup there. So, like I said, does anybody got any questions, or let me ask this: has pretty much everybody heard the term spanning tree before? Okay,
Yes.
okay.
Yes, sir.
Hey, Brian. I know you on that cyber side. Have you heard that spanning tree term before? Uh-oh, did I lose my team lead? Oh, he might have walked away. Okay.
Yeah, I think go ahead.
Okay. So yeah, so like I said, we'll touch base with our team lead Brian a little later on. But as you know, spanning tree, to keep from having layer 2 loops on the VLAN, you know, spanning tree will do its automatic calculations, you know, based on root bridge numbers, and it'll designate, you know, a root bridge where all the BPDUs was going to come out, and the switches downstream are going to take, for the lack of a better term, going to take its marching orders from. Okay. Now, as you know, spanning tree goes through the process, and it will block certain points within the topology so that traffic can pretty much just travel one way. Okay. And because like I said, is if for some reason, if we have a loop, and you've probably heard the term broadcast storms, where, you know, that packet will just pretty much run amok through all the ports until, you know, the CPU dies or whatever, you know. And if you haven't experienced that in the lab or something, I highly recommend setting it up and watching it happen. And actually, if you got access to some real gear, definitely set it up on some real gear and watch it happen. You can actually get it done on if you got access to some dumb switches, you know, like you know how you go to Walmart and you can probably purchase some of those blue, what are those blue switches that they sell? Is it Netgear?
Yeah, Netgear, I think it is.
Yeah, you know, you can set some of them up on there. And actually, I actually have a video on my LinkedIn page where I actually used a couple of those switches, and another switch that was that was pretty much an unmanaged switch. And I had a Cisco 2960, and I plugged it up for about 2 seconds, let a BPU packet come from out of there into those dumb switches, and pretty much it just flooded all the ports on the unmanaged switches. And I pulled the cable out of the 2960, and those LEDs were just blinking like crazy. So like I said, if you get a chance, you know, play around with that, see it in action, see how it goes. And you know, in the lab environment, it might not be that bad when you try to do something in the switches themselves, but in the production environment, when you got actual traffic, you know, that CLI may seem to like lock up on you. You know, it may be like real hard to put a command in there or something like that. But all right, Dave, if you want, you can share the screen, let everybody see what
Perfect.
we're
Okay.
working
Give me
with on
one
the
moment,
topology. Okay.
and I'll go ahead and get into the role of the customer. Okay.
Did Brian ever come back and join us?
Not sure.
Okay.
Doesn't
Ain't no
look
problem.
like
Ain't no
looks like
problem.
he's still in the meeting, but no worries. Okay. Can everybody see my screen?
It's coming up now. It's just taking a little time. There we go.
Yep.
Perfect. Perfect.
Hey, what's going on, guys?
Oh, there you go.
Oh, y'all was talking
Hey,
about me?
Yeah, we was talking to you, but
Oh, my bad.
yeah, you wasn't there.
No worries. No worries. And you know what? Didn't think for that. All right. Yeah, 24 port switch. All right, Claude. Me getting in customer mode. So thank you so much for everything your team has done. Just want to give you an update. We were able to get a second core switch because I did want some of that redundancy. The only thing I fear and I need your team's help with is designing and implementing spanning tree. What I don't want to happen is when all of my users come back in the office from being at home with COVID, that traffic is just not going in a consistent loop and not even reaching the internet, my WAN interfaces on my FortiGates.
Okay.
Can you and your team provide a solution on how to efficiently implement spanning tree?
Okay. All right. So what we got here, we're going to have spanning tree implemented from the distro down to the accesses. The core pretty much is going to sit free of a lot of stuff. The core is mainly for our layer 3 stuff that's happening, you know, to get us out to the World Wide Web. So what we can look to do, we have 1, 2, 3, 4, 5 VLANs. What we can do is over in build number 1, which is on the left-hand side of the screen, you see distro switch 20. All right. So if you guys have done or been exposed to spanning tree, first thing we have to do is we have to select where our root bridge is going to be at. Okay. And, you know, part of this is, you know, you definitely don't want it in the access layer because, you know, sometimes those switches can get replaced and, you know, you don't want your BPDUs coming from the access layer. You know, they need to be flowing from the higher levels down. So with that being said, let me see. Let's see here. Glenn, by chance, have you touched spanning tree or read about spanning tree up to this point?
Yes, sir. Did that in the course that I took at Next Gen T.
Okay. All right. So explain to us how the root bridge is selected.
Now I'm having some problems with that explanation, how the root
Okay.
bridge is connected. If I remember correctly, the root bridge is connected by, I'm trying to remember.
Yeah, how was it selected? How was the root bridge elected? Yeah.
Right. It's coming back to me a little bit.
Okay. All right. So let's let's think about this, and anybody can chime in and pitch in. We know our switches have MAC addresses. Okay.
Correct.
And MAC addresses, if you line them up, for the lack of a better term, they fall in certain order, from lowest to highest, highest to lowest. You know what I mean?
Right.
Okay. So these MAC addresses, you can think of them as a hierarchy where, okay, you got a MAC address that's at this, and I'm just going to use real simple numbers. You have a MAC address that equals 10 on one switch, and you have another MAC address on another switch that equals 20. Okay. So what happens is you have, let's say, some of these older switches that have these real low MAC address numbers because they was made way back in the early 80s, 90s, things like that. So when we have a MAC address that has a low number, how does that affect the root bridge election? And anybody can chime in if they want to help them out.
Wouldn't that be the last one that gets selected?
The switch with the lowest MAC address becomes the root.
Right. So what happens is that low MAC address in the scenario that I explained, where the MAC addresses was 10, 20, and 30, that one that's 10 is going to have what they call the superior BPDUs, and that's going to pretty much that's going to be where the election is pointing to, as far as the root bridge. It's creating the root bridge itself for a given VLAN. Okay. Of course, the next one, but the 20, if for some reason that one with the MAC address falls out of favor, or you just take it out, the switch that has that MAC address that equals 20, that's going to fall in line, and then that's going to have the superior BPDUs. Does that make sense?
Yep.
Okay. All right. So that's one way we can have our elections done. Can anybody tell me of another way we can select our root bridge for a given topology?
You can go in and manually configure which switch you want to become the root.
Yeah, we could do that. We can physically say, all right, we're gonna make this switch the root bridge for XYZ VLANs. Okay. And actually, there's a couple ways we can actually manually do that. You want to elaborate on that?
I think you have to, if I remember, you have to change the priority on the switch.
And let me ask you this: that priority goes from what to what? What's the range on that priority? You remember?
I think the like 0 to like, I think it was like
3,000,
60,000.
60,000,
32.
32.
Oh, 32,000. Okay.
So what was that? I heard somebody saying it. What was that?
I remember 3266. I think I remember.
Things like 768. Some, yeah.
32,768.
Yeah, there you go. There you go. Now, that's the range. Now, Kelvin, let me ask you this.
Okay.
So when you're doing it in that fashion, can you just pick any number between 1 and 32,768?
No, you can't.
Why
I
is
don't-
that?
32,768. I'm
So
thinking that's because that's the default value of all switches anyway, right?
right. That's the default value. But let me ask you this. Based on what you said, can I go into a switch and set its priority to 100? Thinking that that's pretty low. Will it let me do that?
Um,
And if you're unsure, that's fine.
yeah, I'm not sure.
Okay. So the thing is, when it comes to manually putting in that priority bridge number, we have to do it in increments of 4,096.
Oh yeah, I remember now.
Okay. You got to do it in increments of 4,096. And, depending on how complicated your topology is, that's a lot of fingers and toes to be counting when you got hundreds and switches that you got to be dealing with.
Right.
Okay. So that's one way. Is there an easier way that anybody can think of that we can select our root bridge? And it's a manual process as well.
You
You
can,
can,
I'm going to take a crack at this, and I hope I'm right. It's not
Go ahead,
just
Aaron.
guessing.
Go ahead.
Is it always under spanning tree? Is it always 0? The root bridge is always 0.
No, the root bridge always starts at it's the MAC address plus the 32,768.
Okay.
but it depends on when you power on the device, like which order you power on the device.
No. That might be, you might be thinking of HRSP with
Okay.
the standby and stuff. But
So
go ahead, Carlos.
yeah, so I would say it would choose based on the bridge ID, and that's a combination of the two things that we already mentioned, the MAC address of the device and the priority. So let's say we have the default 32,768.
Yeah.
The tiebreaker there would be, let's say, the MAC address.
Mhm.
I mean, of course, you'd want to configure that. You want to leave it,
Right.
but I would say the bridge ID would be the determinant factor.
That's the determining factor, right? So, like I said, when we on that top on that, we determined that there's a couple ways that we can actually force that root bridge selection, and we determined that we can do it manually. And Kelvin was talking about the priority of the bridge itself, of the switch itself. Is there, and like I said, I'm sitting here thinking, is there another way that we can do it besides trying to count our fingers and toes of increments of 4,096? Does anybody got anything?
I forget.
Okay, so there's a simple command that you probably may have, and you may have forgotten it. You may have forgotten it.
Oh,
But you want to say it?
spanning through root.
There you go. Yeah. So if you do it in that fashion, now you let the actual CPU determine the increments of 4,096. You see what I'm saying? So the spanning tree, you set, what is it? Spanning tree,
Root bridge.
root bridge, and I think it's what is it? Matter of fact, let me pull a switch up real quick. I think it's primary and secondary is the commands.
And you put spanning tree, you designate, if we're doing layer 2, you designate what VLAN is going to be in. You say root and then primary.
Yeah. And what that does, that forces the CPU to determine the increments of 4,096. And what it will do is it will poll all the switches within this topology and figure out what their bridge IDs are, and then it will take it as low as it needs to for it to become the root. Does that make sense?
Okay. Yeah, it's coming back. It's coming back.
Okay, not a problem. Anybody got any questions so far?
I'm just soaking it all in, man.
All right, Brian, that's cool. It's cool. All right, so let me ask you this. Does anybody want to take a shot at the port states that Spanning Tree will send the ports through?
It's like a forwarding state and
Yeah, that's one of them. Yep.
Blocking.
yeah,
Mhm.
blocking and forwarding.
Is there any other ones? Think about our regular Spanning Tree, PVST. Okay. So we got
Listening and learning.
listening and learning, right? So we got that MAC address thing going on when we're listening and learning.
Oh
Okay.
yeah, listening and learning.
Yeah.
Was it right?
Yeah. And then there's also one, depending on what text you read, it's called disabled.
Disabled.
You know, yeah, that's where it starts off at.
Okay.
Let me see. Are you familiar with the port roles? So you understand the port, you know the port states. Do you know the port roles?
Mhm.
Anybody want to take a shot?
Port roles. Let's see.
And,
I-
and I'm
Already
gonna take
designated. Listening and learning.
I'm gonna
Go-
take a break from being the customer. Guys, feel free to Google whatever you have to do. Okay.
Oh yeah. Oh yeah.
Because this is something that on your exam, your CCNA or your MP, you're going to see, and they're going to make you trip up on purpose. Know the difference between roles and states. During this lab, we're going to do a Wireshark capture so the concept can actually make sense once we converge switches within spanning tree topology. But again, if you don't know it, Google it, answer it so it can make sense and save it in your brain.
Right.
Because this is something you guys are going to see on the exam, and one mishap may cause you the exam and $300 down the drain. Go ahead, Clark.
All right. So
I think I found them.
okay, what you got?
Designated port role,
Mm-hmm.
alternate and backup port roles,
Okay.
designated port roles, root port roles. I think those are the only ones that I've seen.
Okay. All right. So let me ask you this.
Mhm.
Does anybody want to take a crack at the scenario? Is we already have our root bridge selected. Okay. So our root bridge is selected. Can somebody tell me which port role will the ports be on that root bridge switch?
On the root bridge switch.
Yeah.
Ask the question one more time, please.
Okay. So we've identified our root bridge, right?
Okay.
The ports on that root bridge will be doing what? Because all the ports that's connected to something will be doing the same thing. What will
Yeah.
they be?
The ones on a root bridge would be designated.
Exactly. So you remember I said earlier, I said the root bridge, once it's selected, it's going to be calling the shots
Yeah.
to all the other switches downstream. So that means all the ports that have something on the other end, they're going to be in a forwarding state. They're going to be they're going to be in a designated state.
Oh, now that I'm looking at the definition of designated root port, designated port role, it makes sense.
Okay. Okay. Now, here's another question. All the switches that have a link that point back to that root bridge, what port role will that be?
The root port.
That be listening.
That'd be
It
the
could
root port.
it could be listening, it could be. That's a port state, but what is the port role is going to be in?
The role. But
Root-
Yeah,
The root port.
exactly.
Root port.
Exactly. Let me see. So a port that is not forwarding, okay, and we're talking about a non-root bridge switch, a non-root bridge switch that is not forwarding, okay, but is still listening for MAC addresses, but is not forwarding. What would that port role be in?
Lock in.
Alternate.
Yeah,
Alternate.
it could be. Yeah, yeah. So what does the alternate, what is the purpose of the alternate?
A backup. Well, here's to the backup port that receives more useful BPDUs from the same bridge it is on as a port block.
Okay, so the alternate, picture the alternate being ready to step in if the root port for some reason goes down. So remember we talked about the root port being that link that goes back to the root bridge switch. The alternate is looking for that root bridge switch to go down. And if it does, the alternate is going to jump in this place and change its status. Does that make sense?
Yes.
Okay. All right. So I think we did enough of that, David. So yeah, this looking like one of those LinkedIn.
Different ones from LinkedIn.
This looking like one of the ones from LinkedIn right here. This thing here.
Mm-hmm. I seen one the other day that I saved. I took a screenshot of it. I said, I'm gonna send this to one of y'all. That thing right there had my brain hurting. It was on another level for it.
I have a question.
Yeah, what's that?
Regarding the port roles, can the ports only be when they are disabled? They can only be disabled when they're administratively disabled, right? They don't.
Correct.
Okay.
Correct. Yep, admin down is what they call it.
Okay.
Hey, Claude, check Slack.
Okay, hold on a second. Oh yeah, see that?
I have a question, right?
Yeah, go ahead.
So there was a situation the other day where there was like high CPU utilization, but that wasn't the symptom. There was like a graph, right, that one of my co-mates showed me. He said
Yeah.
there's a potential loop in the network, right?
Yeah, what you're probably looking at, that graph on the CPU processor history.
Yeah, CPU
Where-
show
yeah,
CPU process history.
Yeah, where it gives you a, what is it? What at the time? No, the one is like a 60-minute, a 1 minute, and then it's like
Yeah.
a 72-hour one or something like that.
Right.
Yeah. So what that actually does is it's almost like how Windows has the in the task manager where your CPU is running, 90%, whatever it is, that lets you know that something's hogging resources. Yeah, so a lot of times if you are in a situation where you have a storm going on, somehow spanning tree failed or you got some kind of loop somewhere, and if by chance, if you can get to the CLI to put that command in and put that command at that CPU process command history, you will see the utilization, if you got it within like a 1 minute capture or something like that, you'll see that utilization go on that graph, 90s easily, maybe even 100. And so what was the scenario that you came across?
Yeah, well, the graph that he used was like an external one, right? Like monitoring. So
Okay.
I went on the device and I was able to do that, and it was like 999 at the top.
Yeah.
And then it started to decline on the graph for like an hour. But I was trying to find out how did that loop happen. But then we found out that there was like a retrofit happening at the same time, and maybe somebody plugged in a cable the wrong place. But
Yeah.
that was my question to you, like what scenarios really are we talking about that would cause those
Loops.
loops to happen?
Well, you know, sometimes we can have people come in into the workplace and if it's one of those, you know, where the IT's kind of slack, sometimes people can plug up their own little devices.
Yeah,
You
they
know,
bring their own routers in.
yeah,
Their own switches, right?
you know, they may be at their desk and, you know, they got one data jack that's in the wall where their workstation is. And it's like, okay, well, I need another jack for this, another jack for that, you know. So they may go to Walmart and, you know, they'll go get them little dumb switch or something like that. And like somebody said, you know, they'll bring their own devices in. They can bring their own devices in. Another scenario, and some of you may already know this as well, documentation sometimes isn't the best. You can work at a place for 6 months, a year, 4 years, 5 years, and documentation isn't kept up regularly. Okay. And you make a change on something, or somebody makes a change on something because there was a problem that needed to be fixed at that time, a band-aid. We'll call it a band-aid for short, you know, and they'll fix it, not realizing that they possibly broke something else. Does anybody ever run into that? Okay.
Oh, always.
Oh, you run into it? Okay. But yeah, so sometimes, let me see what else can happen. That's a good scenario. What could I do to literally disable, other than physically in the config disabling spanning tree? I know just the other day I had on my switch, I got an error. It was actually a loopback error. I got a loopback error. And what was happening was I started looking up my switch and found out that as long as I had my switches, there was a bug on it that never came out. And it came out a couple nights ago. And it was in reference to keep alives. And what it was, it told me what the error was. It told me that the keep alive was coming through. It was coming back on the same port that it was going out on, which was creating a loop. And it was, of course, it was shutting. It was set. I had it set up in a port channel, and of course, it shut down all the other links in that port channel because it went into an error disabled state. So that's a scenario where, you know, a layer 2 loop was detected, and fortunately, it was able to correct itself and get that port out of there and shut it down. Let's see. I thought maybe I might have had that.
Thanks, Claude.
Yeah, no problem. I thought maybe I might have had. Oh yeah, here it is. I'm going to put this in the Slack project just for illustration purposes, but you'll see the actual error that is spit out at me. Yeah, I'm gonna drop this in the project. No, I'm gonna drop it into the growth. Yeah, so that way everybody can look at that there. But like I said, and what that loop back, because I didn't have a loop back plugged into that specific port, but what it was tied to was a like I said, a keep alive that was causing me headache. So what I had to do was I had to go in and actually turn keep alives off for that port itself, and everything was fine. It quieted down. All right. Does anybody else got anything else? Dave, I think we may have actually me see, it's 10 minutes to 9 now. You know what? We may have to, since this was kind of a meet and greet with everybody, we may have to just make this session that, just talking about spanning tree, and we may have to implement on our next, seeing what time it is. We may have to
Sounds
implement
good.
on our next one.
Sounds good.
Yeah, but that's no
Down for
problem.
that.
Like I said, because we got some new members in here. You know, we're getting to know one another still, and like I said, this to give everybody a little bit more time to maybe look at spanning tree a little bit closer. And like I said, what we'll do is we'll set up a the distribution switches to be routes on specific VLANs, and we'll set up like I said, the redundant distribution switch to be routes on other VLANs. So we got, I want to say we have four VLANs total. So we can split them between the two, and we can watch how that actually propagates down through the tree. But like I said, this will give everybody time to go ahead and read a little bit more on spanning tree, and then we can come back and we can actually get into the configurations of it itself. But like I said, there was nothing wasted here at all. You know, I know we didn't get a chance to do any CLI stuff, but yeah, there was nothing wasted here at all. Like I said, we got a couple questions out of the way. You know, we kind of filling each other out, you know, which is always a good thing, in my opinion.
Oh yeah, man. I appreciate your guys' time. This refreshing my memory. So it's good stuff, man.
Yeah.
I
And like I
guess
said,
it's just started getting into my memory. So
yeah. Some of y'all, it's going to be new. It's going to be new. Some of y'all, like I said, y'all have touched it before, you know. And like I said, I know you probably heard of PVST. You probably heard of rapid spanning tree, and some of y'all probably going to hear of multiple spanning tree. You know.
Right.
But yeah, like I said, so but right now, just if you can find a little bit of time here and there, just go ahead and read up on the regular spanning tree. And when we come back next week, you know, everybody should have an idea of what we need to do and how it needs to look, you know, and we can get it popping then.
Okay, sounds good, sir.
All right, David, you got any objections?
All good. All good. I'll go ahead and implement that second core switch, and I will upload that picture to the share file with your team, and I'll need you guys to plan spanning tree and let me know how most of my clients' packets from the computer will take towards the gateway. Good deal.
Good deal.
Thank you.
All right, everybody. It was a pleasure. You know, I'm hoping to see y'all, you know, popping in the Slack room, you know, with different questions and stuff. Because like I said, you know, somebody's on at some given time of the day. And if you don't know, if any of y'all guys are third shifters, Brian would be on in the middle of the night. You know, yeah. Brian
look,
will.
man, I can't help I work at night. So I mean, look,
by 11:30, by 11:30, 11:45, you gonna see a message that says anybody up. That's him.
Yeah, I just need any of y'all to be ready to go at any time.
By that time, Brian is warming up cookies and warming up his milk. And,
hey, I'm getting ready to kick my feet up because I'm about to go right on the street.
and then, you know, occasionally, every now and then, you know, we'll start chiming in around 9 o'clock-ish, you know, every so often, you know, myself, Dave, or somebody might be up doing a lab in the middle of the night, you know, looking at trying to work on some personal stuff. If you haven't known already, I post a lot of snapshots in the different rooms. You know, we got
I have it's written out on the board, so it'll be something you have to see as we're going over it.
Okay.
I'm in this study session now. Hopefully, I think it's about to end. Oh, excuse me.
Okay. And like I said, we got plenty of rooms where you see the CCNA question of the day, CCNP question of the day.
There should be a BC in there.
Okay.
Hey, can I ask you a question? That top,
I was gonna say the water behind the seat, but that's gonna be, well, I mean, it ain't too terrible. It's actually not as bad as drinking it with something, because drinking it
Okay,
can I
he's
ask you
muted.
a
Go ahead,
question?
guys. Yeah, go ahead.
That topology that you're using, is that Eve NG
Yeah, it is.
that you're using for the lab?
Yeah. Oh yeah. Oh yeah.
Okay. Cool.
Yeah, he
I
proud
haven't
of
got
that
into
thing.
that one yet.
Yeah.
That's the one okay, cool.
Glenn, I'm gonna tell you, Dave proud of that Eve. I'm gonna let you know. I'm gonna let you know right now. He proud of that thing.
Right. Looks good. I'm gonna check it out.
Yeah, he proud of that
Claude
thing.
gonna give me you know, he gonna give me dirt every time. But hey, caught it on a deal. You know, again, I got it for my CCIE studies, guys, but it's more so. I thought, and Claude can attest to this, and Jermaine can attest to this too. For our labs, I mainly got it for you guys. I want this to be as easy as possible. I also ordered some extra RAM, so our, the box that's running Eve is going to have at least 96 gigs of RAM. It already has 5 terabytes of SSD, so we're going to push it to the limit in these labs.
Nice.
See, I told you. I told you.
See, we're messing with the big boys here, man.
I told you. He got that thing specced out.
Nice.
Oh,
all right,
man. But guys, seriously, again, great responses today. Great question. Again, we're go time. I'm gonna go ahead and paste a diagram, a Visio of me being the customer's topology, and I need you guys to map out how you guys, because you guys are my pro services. So I need you guys to map out who's going to be the route, who's going to be the secondary route for each building, for my core switches, however you guys want to do it. I need to know how, whenever packets come in from my clients, what path are they going to take to reach the internet, okay?
Okay.
All right, and I also need you guys to go ahead and start thinking about layer 3, because again, we're going to go ahead and we have to implement some FortiGate firewalls. Okay.
All right.
Hey, don't let Dave intimidate you. He's a real good guy. He's a real good guy. I know he can come off as like a bulldog sometimes.
Nah, says who, Claude? Says who?
Yeah, but Dave's a good guy, he knows his stuff, and and the thing about Dave and I and Jermaine as well, if we say something or we post something that's incorrect or somewhat misleading, we will correct each other, and that's all out of love. You know what I mean? It's not a thing of trying. That's the reason why Dave brought this group together, so that we can all make mistakes here in front of us before we go out into the industry and make mistakes in front of them. You see what I'm saying?
Well,
Right.
Dave will actually make you become an engineer, so you'll have to ask your own self questions before you ask anybody else questions. So just a heads up, everybody, before y'all get to posting stuff. And you better have a question first.
So he gonna come back with a question.
Exactly. It's gonna be, well, what do we do first before we got to this point? Did you look at any documentation? That's it.
Right.
That's it, man. Shout out to Dave.
and-
He helped us a lot of us out in our Discord little class that we was having, and he challenged us big time. Good stuff.
Okay, so yeah, y'all guys, y'all can have a good night. Dave, Jermaine, if you got anything y'all want to add.
Nah, I'm good. Again, guys, great job. Again, take a look at resources. I'm gonna drop some goodies in there. If you're not part of resources, let me know. The resources I'm gonna drop, it's just goodies for folks that jumped in. It may be prep labs, it may be some docs, who knows? But I need you guys to post in the group, in the main chat, saying that you guys are interested, and I'll go ahead and post those, whatever goodies I'm gonna drop in for you. That's all I got. But again, great job, guys.
All right, cool.
Thank you.
I'll let you know. I'm definitely interested.
Yeah, same here.
Jermaine, you got anything you want to add?
Yeah, I was just gonna say, man, I like how the group is growing, man. I love this. This is a good. It's pretty good, man. I'm loving it. I like how we're working together and growing together. This is awesome. Shoot, I'm seeing automation as a channel now. I want to jump into that.
Let me go ahead and warn y'all about Jermaine. Okay, good guy, right? He's one of y'all other senior engineers in this chat, so y'all gonna be challenged too. So just be ready. He's gonna put y'all on your heels.
Yeah.
But he's a good guy though.
Yeah.
We're all good.
100%.
Yeah, Jermaine, let me tell you, Jermaine will sit in the corner for the duration of the time, and he'll crack you over the head at the last minute when you ready to go.
Yeah.
Jermaine will be quiet. You know, Jermaine will come in the room, you won't even know it. You know, you won't even know it.
It's all good, man.
He'll just ask you, you know, a good question that'll challenge you. Like, I didn't think about that. And it's good, right? Because I want you guys to be, whenever you guys get out in this world, right? Some of the things that I've experienced, and Claude and Jermaine experienced too, is nobody's going to help you out there, right? So we want to turn you guys into engineers that think beyond just what's in front of you, right? You guys have the ability, you know, I know all you guys join the Slack, you guys have the ability to be great. So with this, you know, lab project, with the guys that are in here, guys and gals that are in here, keep networking, keep going at it. You know, it might be hard, you know, you guys may be sacrificing a lot, but it's all for the greater good of you guys, rest of your lives and your careers, okay?
Facts.
Absolutely.
Thank you, sir.
Thank you.
And on that note, I'm going to go ahead and close it. I need to play some Call of Duty. I'll see y'all next Wednesday.
You're not playing Modern Warfare 3, are you?
Nah, man.
All right.
All right, fellas.
fellas.
Take care.
All right.
Be
Y'all
good.
take it easy, man.
All
Take
right,
care.
guys.
Good
Take
stuff.
care.